In this video, we're going to have a look at algebraic proof. So I picked out three different questions here. One's disproving a statement by showing a counterexample. One's using algebraic proof, and another one is kind of like using algebra, but there's a few ways of doing this question, which is why I wanted to go through it. So how can you prove that a quadratic is always positive? Well, if we think about it graphically, when is a quadratic always positive in terms of y? Well, two things. We know that because it has a U shape, if it never crosses the x-axis, then it'll always be above the x-axis. So you can say in that way, it'll always be positive. Another thing you can do, you can find the minimum point of the quadratic by completing the square, and then say, well, if the minimum point is still higher than the x-axis, it's still going to be positive, and all other points which are higher than that will definitely always be positive. So let's use that method here, completing the square. Just to remind you guys how to do it, you take the coefficient of x, which is the number before x, and you half it. So that's minus 2. You put that in a bracket with x, and you square that whole bracket. Now, when you square a bracket, what you're doing is you're just multiplying that bracket by itself. So I'm just going to write it out twice. And you use that method where you do x times x is x squared, x times minus 2 is minus 2x, minus 2 times x is minus 2x, so those add to give you minus 4x, minus 2 times minus 2 is plus 4. How do we get from this expression that we are currently at to x squared minus 4x plus 7? Well, you have to add an extra 3 to it. That's what tells you that it's x minus 2 all squared plus 3. And how do you get the turning point for that? Well, the x coordinate of the turning point is the inverse of the bracket. So because there's x minus 2 in the bracket, we would say it's positive 2 for the x coordinate. And the y coordinate of the turning point is just this constant at the end, so that's the 3. Now that we have a more accurate representation, this is an inaccurate graph, we know the minimum point is 2, 3, which let's say is here. And if all the other coordinates are higher than that minimum point, that shows that it's always positive. Hopefully that makes sense to you guys. You guys might have had another clever idea if you've done the topic of discriminant. What we know about the discriminant is it tells you how many roots an equation has. So here, if you show that the discriminant b squared minus 4ac is less than 0, that means that this quadratic has no roots, so it doesn't cross the x-axis at all. In other words, it'll always be above the x-axis, so it'll always be positive. You can show that here, so let's do that in a different color. So we know all quadratics are in the form ax squared plus bx plus c. A is the number before x squared, which is 1. B is the number before x, which is minus 4. And c is that number at the end, which is 7. Putting them into b squared minus 4ac, we have minus 4 all squared minus 4 multiplied by a multiplied by c. So minus 4 all squared is 16. 4 times 7 is 28. 16 take away 28 is minus 12, which is less than 0. So yeah, that pretty much sums it up. Since b squared minus 4c is less than 0, there's no roots to this quadratic, so it will never touch the x-axis. Moving on now, how do we disprove a statement? Well, the easiest way is you just show one value of n for which this statement is actually false. We call this proof by counterexample. So for example, if you put n equals 1 into this expression, we get 1 squared, take away 1 plus 3, which actually is a prime number, so that doesn't disprove the statement. What about n equals 2? Unfortunately, there's no fancy way of doing this. It's just substituting and then finding one that doesn't work. 2 squared is 4. 4 take away 2 is 2, plus 3 is 5. So that's still a prime number. N equals 3. 3 squared is 9. Take away 3 is 6, plus 3 is 9. Well, that's not prime, because we know 3 times 3 is also 9. So you say something like, since n equals 3 provides a number that is not prime, this disproves the statement via counterexample. Great. Let's now move on to this last one. You might notice this from GCSE Maths, it's at the higher end of the spectrum. Proves that the sum of the squares of two consecutive odd integers is always 2 more than... Okay, it's a lot of information. Let's break this down. So first of all, it's talking about 2 consecutive odd integers. So we know that 2x will always be even because 2 multiplied by any number is always even. If you then add 1 to that, that will be odd because any even number plus 1 is always odd. What's the next odd number after that? Or the next consecutive odd number? Well, thinking about it, if we have the number 3, the next odd number after that is 5. The next odd number after that is 7. So you add 2 to get to the next consecutive odd integer. Meaning if we add 2 to this expression, we get 2x plus 3. And these are 2 consecutive odd integers. What you now want to do is square both of them and then add together the squares of both of them. So let's do that. 2x plus 1 all squared plus 2x plus 3 all squared. So with these massive statements, try breaking them down into sizable chunks. When you're squaring, you're essentially multiplying a bracket by itself. So 2x plus 1, 2x plus 1. 2x times 2x is 4x squared. 2x times 1 is 2x. And then another 1 times 2x is 2x. Those are to give you 4x. And then we have 1 times 1 is 1. Let's write all of that out here. And let's do the same to this bracket on the right. So 2x plus 3, all multiplied by 2x plus 3. Once again, 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. So those add together to give you 12x. And 3 times 3 is actually just 9. So I'm going to cheat a little bit and just drag all this over, so I don't have to write out again. And then you can add those together by collecting like terms. 4x squared plus 4x squared is 8x squared. 4x plus 12x is 16x. And 1 plus 9 is 10. Now let's go into the last part of the question, which is showing that it's always 2 more than a multiple of 8. Well, how can you do that? If you factor out 8 from this expression and then show that it's 8 multiplied by something plus 2, that shows that it's always 2 more than a multiple of 8. So let's do that. We can factor out 8. To go from 8 to 8x squared, you multiply x squared. To go from 8 to 16x, you multiply 2x. To go from 8 to 10, you just multiply 1 actually, because 8 times 1 gets you to 8. So we actually have to split this 10 up into plus 8 plus 2. So you can factor out the 1 just like I did here, and then there's a plus 2 at the end that you just add here. Now, no matter what x value you put into this, it's always going to be 2 more than a multiple of 8. So this is your final answer. Hopefully that all made sense to you guys. Be sure to like the video if it helped and subscribe. If you have something else that you want me to go through, just let me know.